Greetings, everyone. Welcome to Module 4 of the Virtual EV Deployment for Southeast Asia course. Today we'll be discussing workforce development. My name is Alexandra Asnar, and I am the USAID NREL Portfolio Manager. I've been working with USAID in partner countries throughout Southeast Asia and globally on how to best integrate distributed energy resources such as distributed solar and electric vehicles. I'm joined today by my colleague Sanjini Nanayakara, a project lead for the LEDS Global Partnership and USAID NREL portfolio. Today, we'll be talking about 3 different items. First, we'll begin with an introduction to workforce development and explore what is workforce development and why is it important for the EV transition. Then we'll turn to understanding the dynamic nature of the EV transition and how differences between conventional and electric vehicles affect workforce needs. We'll conclude with looking at the EV value chain and workforce opportunities. What truly is the full spectrum of the EV ecosystem's workforce needs? You've learned over the course of this virtual course about some of the key elements to support EV deployment, such as charging infrastructure, standards and codes, tariff design, and grid planning. Today, we'll turn to a critical but often overlooked component of EV market development, workforce development. New technologies, such as EVs, struggle to become mainstream without a larger ecosystem of trained, skilled professionals who provide services that keep EVs operational and safe. On this slide, there is a rendition of the technology adoption curve attributed to Everett Rogers, which provides a framework for how people engage with new technologies such as EVs over time. Early on, innovators and early adopters, curious and eager for new technologies, adopt them, but they are still a niche product. A technology becomes more mainstream as an early and late majority of people adopt the technology, and a technology has fully saturated the market once the laggards finally adopt it. The challenge for EVs is overcoming the chasm between the early and mainstream market. There are numerous tools that can help overcome this chasm, but an important one is cultivating the workforce needed to sustain the EV industry over time. Now that we've briefly discussed the importance of workforce development to enabling the widespread adoption of a new technology, such as electric vehicles, let's talk about what workforce development can entail and what it aims to accomplish. Workforce development aims to ensure that a workforce has the skills, training, and experience needed to support EV deployment and fully take advantage of its economic benefits. It encompasses several strategies that are common across other relatively new renewable energy industries, such as solar and wind. These include 1. Standardized education and training at all levels of education. 2. Industry-based training, certification, and apprenticeships that build professional capacity on an ongoing basis. And 3. Understanding labor market dynamics over time to ensure programs and policies match labor supply with job demand. I'd like to offer a few examples of EV and EVSE education and training programs. For example, first responders such as firefighters or emergency medicine technicians should be trained to safely manage the unique dimensions and risks of EV accidents and emergencies, because EVs have high internal voltages and electrochemical batteries that can pose unique safety risks. In the United States, the National Fire Protection Association offers training and resources on this topic. Another example of EV education and training is the US-based National Alternative Fuels Training Consortium, or NAFTC, whose focus is to provide a training infrastructure for alternative fuel and advanced technology vehicles and other associated technologies. The NAFTC is made up of 46 national training centers that provide post-secondary EV education, largely in community colleges, as well as curriculum for high schools and other organizations. Similarly, the Michigan Alliance for Greater Mobility Advancement is a consortium made of equipment manufacturers, suppliers, educational institutions, workforce development organizations, and government that addresses the automotive industry evolving workforce needs with the emergence of connected, automated, and electrified mobility. Consortium partners work together to assess skills and training gaps and develop education and training programs to fill those needs. Finally, jurisdictions that deploy battery electric buses can leverage technician assistance provided by fleet vehicle manufacturers, who typically include training hours in the purchasing contract. Transit agency staff, local repair shop staff, and even technicians in training from local schools could participate in these trainings. For passenger vehicles, vehicle dealerships could request technician trainings from their manufacturers if available. Jurisdictions can also sponsor technicians to attend certification programs. Technicians will need to be trained to certify EVs for secondary used EV markets and other second life markets for batteries. There may be existing educational institutions, industry partnerships, and workforce development programs in your own countries that could be leveraged to educate and train workers for the EV industry jobs of the future. Now that we've covered examples of EV education and training programs, let's turn to the final, often overlooked element, understanding the needs of the EV labor market. Tracking the EV labor market as it evolves can ensure that policies and programs meet current and evolving industry needs. EV workforce development policies and programs, like their counterparts in the solar and wind industries, must understand and be responsive to labor market, i.e. supply and demand, dynamics in order to prepare a sufficient number of skilled workers for jobs that exist now and will exist in the future. It's important to remember that labor intensity changes over time because as an industry matures, labor productivity typically improves. This slide shows some key labor market factors that decision makers can regularly explore as they build and expand EV deployment. These include the types of occupations needed, the anticipated growth rate for jobs, any current challenges that firms and businesses face with hiring, the size of local job markets and the regional distribution of jobs, typical wages for different EV industry-related jobs, and workforce concerns related to equity and inclusion. Careful exploration of these kinds of questions can help countries seize the economic development opportunities of electric vehicles. Let's look at a few examples of how different jurisdictions are assessing their EV workforce development needs. For example, this figure on the right comes from a 2012 report developed by the Los Angeles County Economic Development Corporation that assessed the barriers and opportunities for EV growth in Los Angeles, including workforce needs and training opportunities. Their analysis indicates the need for a wide range of occupations, from chemical engineers to urban planners to automotive service professionals, needed to support the EV industry in Los Angeles alone, along with expected annual wages. The variety of workforce opportunities can inform the education and training approaches Los Angeles must offer in order to meet the workforce demand of the emerging EV industry. This kind of assessment is an example of understanding labor market dynamics, which can help jurisdictions make data-driven decisions on EV workforce development policies and programs. Another example comes from the U.S. states of Oregon and Washington that jointly evaluated the EV business opportunities in their region, the current and future EV workforce needs, and potential partners to engage for workforce training. In the figure on the right, the authors analyze the occupations that work in industries connected with the electric motor vehicle supply chain in Oregon in 2019, determining production occupations in blue are the most common industries in Oregon related to EVs, and that overall, Oregon and Washington have industries connected to the EV supply chain, indicating that these states have a strong workforce foundation for the coming EV transition. A final example is from Scotland, which developed a Climate Emergency Skills Action Plan in response to Scotland's declaration of a climate emergency and a national net zero emissions target by 2045. The COVID-19 pandemic and economic downturn underscored the importance of critically evaluating and planning for new, high-quality green jobs and preparing the workforce for those jobs. The report focuses on a range of sectors, including transport, and maps out priority areas, skills needed, current activities, areas of future focus, lead organizations and partners, and a general timeline.
Thus far, we have learned how workforce development is a key building block of the EV transition and the greater EV ecosystem, making it critical to establish trained and skilled professionals in order to progress with the decarbonization of transport systems. Let's now move on to thinking ahead. What challenges might the existing labor markets face with greater EV deployment? Electric vehicles are much simpler in design and engineering compared to a gasoline-powered internal combustion engine vehicle, thus consists of a significantly lower number of components and moving parts. As a result of this difference, in the US, it is expected that approximately 150,000 jobs that are linked to the ICE powertrain may be impacted, both in terms of production and engineering. Additionally, a recent report from Fraunhofer, which was commissioned by the German automotive industry, showed the estimated impact on the job market ranging from 2017 to 2030. Of the estimated 75,000 car manufacturing jobs that is estimated to be lost in Germany, about 27% are attributed to electromobility. These concerns around the possible impact to existing jobs have resulted in United Auto Workers in the US calling for greater programs and initiatives to retrain or reskill existing workers to position them for the new job markets. Therefore, in order to design educational and training strategies and policies to ensure local production and job creation, a comprehensive understanding of the future workforce development needs is essential. You have seen a few key case studies and examples in previous slides. Overall, to better understand labor markets, each country will need to assess their own priorities, evaluate local labor markets and supply chains, and carve out a long-term holistic plan to systematically transition their workforce to a potential EV-based economy. Now, let's take a look at the key differences within the two types of vehicles. On the left, we see a schematic of an internal combustion engine or ICE vehicle, and on the right, we see a schematic of an electric vehicle. So what will stay the same? The driver interface and the wheels. What will change? The inner workings of the vehicle and the controls. This means, as shown to the left of the arrow, key components such as the engine, fuel system, exhaust system, transmission, alternator to power auxiliary loads, battery and starter motor will be replaced by EV batteries, electric motors, and power electronics. With this comparison, we can start to think about the types of knowledge and skills that may be needed in workforce development programs. We expect to see an impact to the workers associated with mechanically complex internal combustion engine, transmission, and exhaust systems, while we can expect gains in the need for skills in chemistry, materials, battery assembly, and engineering. Let's take a look at a study that shows what new job types to expect and in what quantities. The figure on the left shows the distribution of new jobs based on the electromobility value chain. Listed on the right are the top 5 job types. Maintenance of electric vehicles makes up an estimated 39% of new jobs. This refers to repairs and maintenance that is associated with the vehicle but not the charging infrastructure. Battery cell manufacturing makes up the second largest possible job sector. Third is installation, and this refers to electric vehicle supply equipment such as charging infrastructure, but also includes customer-facing jobs, planning and administrative jobs, as well as the actual installation. The top 3 types of jobs are followed by those associated with electricity generation and operation of charging points. This study emphasizes a need to understand the ways in which EV deployment may affect traditional auto manufacturing and supply chains, and also to understand what new job sectors to plan for in order to design initiatives for building a new skilled labor force. Finally, I would like to take this opportunity to highlight 2 key resources. First, the Electric Vehicle Toolkit, and second, a report titled Building Blocks of Electric Vehicle Deployment, a Guide for Developing Countries. Both of these offer a framework for developing countries to enable short and long-term planning for policymakers, regulators, and other decision makers. And what you will see in these resources is that workforce development is a key pillar in EV deployment, and working on this topic needs to be done in parallel to the other pillars to be able to gain the best economic benefit from the EV transition. Thank you, everyone, and please reach out to us if you have any questions or need additional information. Have a great day.